Hey guys, today we're going to be talking a little bit about symmetry. There are two terms that you will need to know. Okay, the first is symmetry, the second is line symmetry. And so a figure of symmetry, if there is a transformation of the figure such that the image coincides with the pre-image. Okay, so for instance, let's say you had a heart.
The one that we're looking at has a finished basement.
And let's go ahead and say that heart is equal on both sides, that it was a symmetric figure on both sides. And so if you flipped that heart in half, then you would end up having symmetry in that heart. And the second one, a figure has line symmetry if it can be reflected across a line so that the image coincides with the pre-image. So using that heart example again, if you were to draw a line right down the middle and flip this thing over here, it would land right on top of itself. Okay, so that is line symmetry. Sorry for the bad picture. Okay, so let's just go through a couple of different examples and see if these examples have symmetry or line symmetry. Okay, so example number one, we got this little explosion. Okay, so you want to find if there are any parts of that shape that have line symmetry. Of course, you can draw one here, you can draw one here, 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 and so on. And so if you drew all of them, there would actually be 8 different line symmetries. So this one is yes, and you would have 8 different lines if you did all of them. Okay, example number 2, you just got this little triangle guy. Well, there's nowhere that you can split that to where it'll be completely symmetric. So in this one, we have no symmetry. Okay, so no symmetry on that one. Alright, let's take a look at this little cross-looking guy. Okay, this one has a bunch of different ones. You could draw one directly through the diagonals on both sides, or you could draw some right here. Okay, so there happen to be, yes, there are 4 of them. Okay, and lastly, we got our little b, and on this one, we only have the one line of symmetry. So yes, there is just one of them. Okay, your next term that you need to know is rotational symmetry. And rotational symmetry is if it can be rotated about a point by an angle greater than 0 degrees and less than 360, so that the image coincides with the pre-image. Okay, so for instance, let's say you had a square. If you rotated this thing, this direction 90 degrees, well, you would still have a square, but the point that was up here would now be located down here. And so that's what that is talking about. Okay, so go ahead and flip to the next page. Okay, and let's look at the term at the top. Okay, it says the angle of rotational symmetry is the smallest angle through which a figure can be rotated to land on top of itself. Okay, and the number of times a figure coincides with itself or lands on top of itself through 360 degrees is called the order. So the amount of times it lands on top of itself is called the order. So that example I was just talking about, the square. Okay, so if you rotated this thing 360 degrees, 90 degrees, 180, 270, 360. Every time you rotated 90 degrees, that square would land on top of itself. Well, at each one of those different spots, your order would increase by 1. So for the square, if you rotated at 360 degrees, you would land on itself 4 times, so your order would be, in fact, 4. Okay, so let's go through a couple of examples and decide if these have rotational symmetry, and let's decide the order that this thing would have. Okay, so example number 5, that's kind of a weird little shape. No matter how you rotate that thing, you're not going to be able to land on itself. Okay, so there is no rotational symmetry. Okay, so there's none at all. Okay, but example number 6, if we rotated this thing 180 degrees, that thing would land on top of itself. And if you rotated it again, it would land on top of itself again. So if you rotated it 360 degrees, it would land on top of itself twice. So it's yes. And the order is 2. Okay, one more. So this time, we're rotating this thing 360 degrees and seeing how many times it'll land on top of itself. So let's say these are all 90 degrees. Since it's a circle and there's 4 different segments, there's 90 degrees. So if we rotated this thing, rotate it once, the order is 1. Rotate it twice, order 2, 3, 4. And so that thing would have symmetry, a rotational symmetry, and it would have an order of 4. And let's look at 2 more examples for this thing. Example number 8 is going to be just like a square. Every time you rotate this thing 90 degrees, your order will increase by 1 until you get to 360. So we got 1, 2, 3, and 4. So yes, this thing has rotational symmetry, and you would have an order of 4. Okay, and example number 9. This thing is a circle and it's divided into 2 halves, so every time you rotate this thing 180 degrees, your order is going to increase by 1. Okay, so yes, this has rotational symmetry, and it has an order of 2. Okay, go ahead and flip to your next page. Oops. Alright. Okay, the last thing we're going to be talking about is plane symmetry. And your term says, if a plane can divide the figure into 2 congruent reflected halves, it is, in fact, plane symmetry. And your other term on here, it says a 3-dimensional figure has symmetry about an axis. If there is a line about which the figure can be rotated between 0 and 360, the image coincides with the pre-image. Okay, so we want to decide if these different figures provided have plane symmetry, symmetry about an axis, or neither. Okay, so on this little pyramid, you can divide this thing right down the middle, and that thing will have plane symmetry. It creates 2 congruent halves. You could also draw a line that goes right down the middle, kind of like this, and that if you rotated it between 0 and 360 degrees, the image would look the same. Okay, so this shape has plane symmetry and symmetry about an axis. Okay, so symmetry about an axis. I'm not going to write all that down. Okay, second example, you have this little L shape, and you can divide this thing right down the middle. If I can get the pen tool up. Okay, so you can divide that down the middle into two congruent parts, but you cannot draw a line right down the middle of the axis and create a similar object. So this one, you just have plane symmetry. And your last example. And we have this little cone shape. And on this one, you can draw a line right down the middle, and it creates 2 congruent spots, so that is going to be plane symmetry. And if you were looking down on that shape and it goes right through the middle, if you rotate that shape, in fact, it will be the same image no matter how you rotate that. So that will give you symmetry about an axis. Okay, so go ahead and review all these if you need to. And go ahead and get started on your homework. Have a great one, guys. Bye-bye.